Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we're going to continue our lesson for week 7. Okay, open the slideshow. Okay, so week 7. Last week we have covered the XBeach modules, which is the flow module, and we have learned about the lot of equations, and of course on the short shallow water equations, the tide, the currents, wave setup, and how it's going to influence the infragravity waves. And of course, the flow module will result in the water level and current, which going to influence the sediment module. So here in the sediment module, uh, it will happen the fact that it will uh, influence the steering, the advection, and also diffusion, which mean the concentrations and also the sediment transport. So what the steering, you I think most of you know what is steering. Advection, basically the transport processes. Inside the environment in the ocean, they can be divided into these two category: advection and diffusion. Whereas the advection refers to the transport with mean fluid flow. With this mean flow, so this advection shows you that, like I mentioned last week, for example, the pollutants, when the wind blow from east to west, so the pollutants too will follow the wind together from east to west. So that's what we call the advection. While diffusion refers to the action of random motion of the sediment transport. So because sediment made of sand, in XBeach we only cover sand, not gravel type or cohesive like mud. So they have a random movement as well when combined with steering and also advection. Okay, moving on. This is the advection diffusion term. It will cover the mean flow and also the random motion of the sediment. And because of that, erosion and deposition, they they are influenced by this advection and diffusion equation. They provide important source term. Okay, because of why this source term is important. Where's my the source sink term? The source sink term will always be on the right hand side of the equation. Okay, this is the Newton law, second Newton law, where the advection and diffusion happen, and it's equalized, balanced by the source sink term, because this source term is very important for the bed level elevation, for the morphology. Okay, and it's defined the erosion and deposition uh, phenomena. Okay, um, and they are solved in depth average form, and that is the reason why we using a depth average, two-dimensional advection diffusion, this one, with a source sink term, this one, based on equilibrium sediment concentration. Okay, because the source sink term here, they akan represent from erosional to the eventual deposition. So the sediment routing system is from the equilibrium concentration berapa banyak dia berubah. Okay. So the C represent the depth average sediment concentration, the C, which varies on the wave group time scale, and DH is the sediment diffusion coefficient. So this one will be coefficient number. You don't have to worry about that. The entrainment of the sediment is represented by adaptation time. Okay, this I will explain later. Given by a simple approximation based on the local water depth, H, and sediment fall velocity. So this is one the most important one because it relates to the geometry of the sediment and how it's going to be suspended or not depends on the sediment fall velocity. Okay, moving on. Okay, the small value, the time scale t, actually used in which the sediment concentration adapts to the equilibrium concentration. So we have two tadi, the C equilibrium concentration, equilibrium, and juga the sediment concentration. So the T ni dia represent the how the sediment concentration to adapt to the equilibrium. So they represent the fact that deposition depends on the near bed sediment concentration rather than the depth average value. So the sediment concentration profile ni need some time to adapt to the equilibrium punya profile, and that is what the TS itu represent. And the mismatch between the C and the C equilibrium will represent either it is being deposited or eroded. For example, if C is more than C equilibrium, then it will result in deposited. Okay, and if C is less than C equilibrium, then it will eroded. Okay, so that's the relationship. And inside this time scale, then kita ada this one, the sediment fall velocity. Fall velocity, which play also a very uh, big role in determine the how the movement of each particle inside each sediment particles. Okay. Next, to summarize, again, I summarize again, advection. So this is the change. We have the right, left hand side of the equation. Left hand side is the left hand side, and this is the right hand side of the equation. Depth, average line integrated, advection, diffusion equation. So this term is change in concentration. Okay. And second term is sediment transport advection. So advection again is the motion of particles along the mean flow. And then this one is net movement of particle from high concentration to low concentration, meaning that random lah. Like if you drop like one ink inside a glass of water, you can see it's spreading out. So there is like the random motion of the ink into the glass of water. Okay, uh, and the H is a local water depth, where C is the depth average sediment concentration, and DH is sediment diffusion coefficient. And this is what we call the pickup function or the source sink term that determine the route, the sedimentation route. Either it's going to be eroded or deposited. Okay, based on this time scale. So inside here we have the velocity for sediment, and you can see it is equal to velocity of Eulerian plus the velocity of AS and SK. And this one you can refer back in the XBeach manual, whereas the AS is asymmetry and SK is Qness, meaning if you use a non-hydrostatic punya module, you don't use a simple one like linear, you want a non-hydrostatic, you don't want a surf bead punya module, so meaning that you have to include the nonlinearity inside this velocity for sediment. And we learned last week as well, for the sedimentation usually they use Eulerian because the advection move in mean flow, so mean flow is mostly Eulerian lah. Eulerian motion. And this is what we learned tadi. The source sink term basically defined by a time scale where we have the sediment fall velocity. Okay. So pick up function base difference between current punya concentration, ni current punya concentration level, and the equilibrium concentration as well as the characteristic time scale. So kita tekankan sekali lagi, because why? After this we're going to look on how the sediment fall velocity influence the current concentration level and the equilibrium concentration. Advection velocity include return flow and wave skewness asymmetry effect. Okay, this one I already mentioned. This is optional if you want to uh, use it. Return flow to Stokes, because we learn the drift stoke and everything too. And but this one is already included in XBeach. No, you don't have to worry about that. Okay, next is general parameters. In the sediment transport punya formulation, the equilibrium sediment CEQ for the both bed load dengan suspended load is related. Okay, macam mana kita, this the general parameters answering how do you define the equilibrium sediment concentration, the first initial profile yang equilibrium, dalam equilibrium state, they related to first velocity magnitude, orbital velocity, or root mean square, and the fall velocity. So these three velocity yang influence the equilibrium state of the sediment concentration. Important to note, XBeach calculate the equilibrium concentration for the bed and suspended load separately. Okay. Okay, first of all, going to the Eulerian velocity magnitude, ada tiga tadi ya. If long wave steering is turned on, keyword, the velocity magnitude is equal to the magnitude of the Eulerian velocity as can be seen in equation 2.73. So meaning that the velocity magnitude sama je dengan Eulerian velocity of daripada X and Y. Tambah je dapat je velocity magnitude dia of the mean flow tu. Kalau turn off, the velocity magnitude will be determined by two terms. First of all, factor of the velocity magnitude of the previous time step. Secondly, a current average part. Averaging will be carried out based on certain factor. So if you choose not to consider it, it will basically go back to the default value using this 1 or 2, 4.0. Then this is the representative of when you want to use the number 1 or 2. Right, don't have to worry about this. This is just for your knowledge only. Okay. So secondly, the root mean square velocity. U mu RMS is obtained from the wave group varying with energy using linear wave theory. Okay, so kenapa dia pakai URMS? Dia measure of the speed of sediment. They define as velocity. Average velocity square of the sediment. So the reason we use of the average because of the since particle moving in all direction, the steering everything. So kita nak determine both diffusion rates tu, kita guna root mean square velocity. Maksudnya root mean square ni to add everyone average velocity square by sediment. Square root kan. Okay. Lepas tu dalam ni dia ada uh, dia punya K ni. Small K ni wave breaking. Masa ni lah kita masukkan wave breaking everything. Semua the turbulence juga dimasukkan dalam sini. Okay. And thirdly, the fall velocity. Okay. Fall velocity ni calculated using formulation, ada banyak lah formulation dia. So di sini nanti you guys seen this one before, the D50. It's a sieve analysis. D50 masuk 50% of the cumulative mass. Diameter of the particle that 50% of a sample mass is smaller than 50% of a sample mass is larger than. So 50% ni maksudnya. A is surface area. So for high sediment concentration, the fall velocity is reduced using expression of Richardson. And the exponent alpha is estimated using the equation of rho, which depend purely on the Reynolds particle number. So Reynolds particle number ni nak tunjukkan sama ada satu flow tu is turbulence or laminar. Laminar. Okay. In the present version of XBeach, two sediment transport formulation are available. Maksudnya, if you guys you guys do research probably in the future in sediment transport, then you have to focus more on this module, this part. Kalau tidak, you just ambil je semua default, okay je. The formulae of two formulation are presented in the following one. And in this equation, the minimum value of the equilibrium sediment concentration, the CEQ, compared to the maximum allowed sediment concentration keyword. Okay. 2.3 maksudnya, for both method, sediment transport ni, total equilibrium sediment tu calculated by this equation. Okay. Apa yang kita terang lagi? Okay, untuk transport formulation, how kita nak transport the sediment tu, especially dia kira beza, distinguish the bed load dengan suspended load differently. And it's possible untuk kita nak exclude this transport component. Maksudnya kita tak nak kira suspended, we just want to calculate the bed load saja. So we can choose. And kita boleh juga compute the total bulk transport. Maksudnya these two. Okay, on top of that, this switch will have impact on how the bed slope effect will be calculated. We can choose either this one, or the combination of two, bulk load. Tapi dia takkan boleh distinguish bed load and suspended load tu. Dia kira lain lah. Dia kira. So yang paling famous sekali dua transport formulation nak kira sediment ni yang di implemented, ada banyak sebenarnya for sediment transport punya calculation, but it implement two formulation. Number one is the Soulsby-Van Rijin. So kita tengok sini, yang you guys perlu tahu how dia calculate equilibrium dia. So equilibrium dia sini, and then dia ambil the velocity magnitude of the flow and then the velocity average of every sediment tu, and then dia ada coefficient and UCR. So what is UCR? Ada juga nanti beritahu. For which the bed load and suspended load coefficient are calculated with this ASB ni adalah this part. Here ASB B here, ASS is here. This one is here. Okay. Ini pun sudah being implemented in the XBeach. Just want to let you know that what happened exactly behind the XBeach coding. So if you want to change anything, you can go back to the coding. But if not, or everything is included in the xbeach.exe. Okay. And then you have Soulsby critical, the V, this one, the UCR means UCR here. Means the critical velocity. They define at which depth average velocity sediment motion is initiated. Kat mana velocity sediment motion tu initiated. And dalam sinilah we can see different size of sedimentation is being recorded. And the hash and log. Everything here is to search to determine the critical velocity. In this equation, Z0 is used for the bed roughness length and is used as zero flow velocity level in the formulation of the sediment concentration. So once you do a sediment concentration everything, barulah you ambil kira all these numbers. Okay. And second one will be the Van Rijin. The major difference between the Soulsby-Van Rijin equation is twofold. Beza dia dengan this one is Soulsby and this one is Van Til. First of all, there is no drag coefficient calculated anymore. Kat sini perasan tak ada CD nor here. Secondly, the critical velocity UCR is determined by calculating separately the critical velocity for current and for wave. Dipecahkan lagi pula. UCR ni dipecahkan lagi pula dua. Wave satu, current satu. Kat sini lah. Tengok sini. Nampak sini. For which the bed load and suspended load coefficient are calculated with. Okay, ni sama. Tapi dia beza kat sini. The critical velocity is computed separate contribution by currents and wave. Sini for currents. Sini for wave. Which is this adalah dia punya velocity magnitude, and here is the velocity of root mean square. So it's just connected to each other, all these different contribution of current, wave, but the thing is it's everything's related to one objective, just to see how the movement of the transport of the sedimentation, how the transportation of the sediment to work in the flow. Okay, and region. Okay, so this is the critical velocity for current, and this is the critical velocity for wave. You see a lot of number is okay, but once you actually do it, you just actually replace all the value inside this parameter, which is basically just very straightforward. Okay, Next, we have the wave shape. The model considers short wave average, okay, and we resolve the hydrodynamics associated with the wave group timescale. As a result, the short wave shape is not solved for. However, as waves propagate from deep water onto the beach, their surface form and orbital water motion become increasingly non-linear because of the amplification of the higher harmonics. So when you start from here and then you move towards the shore, akan ada banyak turbulence, and the turbulence become increasingly non-linear. Okay, so when there's a non-linearity, there are the effects of with non-linearity, and that is where it's come. If you can refer in the manual, the SK and also AS is the wave skewness and wave asymmetry parameter inside the XBeach manual, which related much to the wave shape and wave nonlinearity. Okay, the effect of wave skewness and the symmetry are accounted for in the advection-diffusion equation repeated here to affect sediment advection velocity. So if this one, if you decided to go for non-hydrostatic, so here dekat bahagian diffusion and also advection, so sorry, advection and diffusion is the acceleration term. You can see dia pecahkan lagi untuk dia nak accounted for wave skewness and wave asymmetry. So, okay, but no worry about that, just for your knowledge. In this equation, dia kata UA is calculated. What is UA? UA here. This is the UA. Is calculated as function of wave skewness, wave asymmetry, root mean square, and two calibration factor. To set both values, one can use the word FACUA, fact UA. Okay. The method to determine the skewness and symmetry is described in section 2.3.4 in XBeach manual. But if you not going to do any type of nonlinearity with skewness and symmetry, is okay. So dia kata a higher value of UA will simulate a stronger onshore sediment transport component. Okay, because apa, dia ada URMS, dia ada symmetry parameter, so dia akan create lagi stronger, lagi accurate nonlinearity. Okay, the next one, hindered erosion by dilatancy. Okay, I will pause a bit for this part. Wait a second and show this card. Okay, continue for the hindered erosion by dilatancy. Okay, under overwash and breaching condition, high flow velocity and large bed level variation in time. Kalau this is where the breaching condition, where we have a lot of you have a high velocity and then they start to breach the bed level, dilatancy might hinder the erosion rates. Okay, just to account for this fact, the theory of Van Rijin could be applied, reducing the critical chill parameter. In this equation, Vc refer to the erosion velocity, K permeability, and 0 is the porosity prior and is porosity in the shear zone. So is the area when you want to make sure tak ada overwash sangat, tak ada breaching condition. So this is the part where you want to look at. Okay. The large the permeability of the bed, the smaller dilatancy punya uh, effect. Okay, this part where you wanted to make sure the K1, yes, because you tak nak dia jadi terlalu attached together, the dilatancy effect tu. Because the larger the permeability tu, dilatancy effect tu semakin kecil. And finally, the erosion velocity is the velocity at which the bottom level decrease. Okay, dilatancy ni kita nak tengok sama ada they become more viscous or solid under pressure. And we want to make sure yang permeability tu tak large sangat, just enough to make sure kita boleh hinder the erosion tu by dilatancy. And next one we have the bad slope effect yang it can affect the sediment transport in various ways. The bad slope influence the local near bed flow velocity. Slope macam mana yang influence, it can change the flow velocity. Bad slope juga boleh change the transport rate once the sediment is in motion. The bad slope also can change the transport direction, transport rate, transport direction, and it also can change the threshold condition for initiation of motion. You have something like this, or if you have something like this, or you have a flat bed slope. So this is the affect the sediment transport. Okay, so two possible expressions are implemented to change the magnitude of sediment transport resulting from the bed slope effects. The first method is the default one in XBeach, where kita ada alpha is 1.6, is alpha. So you ada U, Lagrangian, L. ZB is the bed level. This method could be applied on either the total sediment transport or only on the bed load transport, because you distinguish there between two kan, dia tak suspended dan juga bed load transport. So to change the direction of the bed load transport, the expression of Van Bendigo and Talmont could be used. Ni kita nak change the direction of the bed load transport. Bed load. This one also you don't have to worry because we always going to use the default value. Okay, ni angle between fluid velocity vector and the x-axis. Finally, is also possible kita nak adjust the initiation of motion for the total transport or the bed load transport. Kita boleh adjust melalui theta critical ni. In this equation, different in angle between the flow direction and the on-slope directed vector. Beta is the back slope. I forgot this. And then the angle of repose. This one is okay. No need to worry. Just choose the default value. Okay, and for the summary, just give you a summary of everything you learn about sediment transport. Sediment transport is quite a very huge subject to cover. It's not going to be enough just for a simple explanation. But because of you as an end user of XBeach, you just need to know that sediment transport in XBeach basically is being governed by two: formulation, Van and Soulsby-Van Rijin, to determine the equilibrium sediment concentration. And then equilibrium concentration used in the pickup function, where kita ada 2DH Advection-diffusion equation solved to produce sediment transport vector, total or bed and suspended, either one. Multiple sediment types can be included in a model where each sediment type is calculated using its own grain size. Dia yang tadi tu, grain size. And then influence of turbulence bores, the KV, included juga to increase the shear stress, because the bed shear stress is important in the calculation of sediment transport. And the influence of short wave skewness and wave asymmetry. Dia nak tengok wave shape dan juga sediment advection velocity in nonlinearity lah, nonlinearity, non-hydrosity. Ni tak apa. Limitation dia kata okay, accuracy of sediment transport model depend on validity of sediment transport relation used to determine equilibrium concentration. So it is a lot of formulation, and they use these two formulation only. No vertical profile because this is a depth average. No interaction between multiple sediment. Okay, this is not yet been implemented in XBeach. Okay, and I guess that is all for the sediment transport summary. So if you have any question, we're going to discuss it. Just post in the WhatsApp group or in our Google Classroom. And while doing the next tutorial on accumulation sediment, maybe you will get a further idea on how some parameters, if you change it, what does the effects, what do some certain parameter affect the whole simulation. Okay, by that I think that's all for today. Assalamualaikum warahmatullahi wabarakatuh.